Okay, so straight lines. Straight lines. Now, if you remember, if I had given you an equation last time, suppose if I had given you an equation like this. Now, till last year, what were you doing? You were finding out y in terms of x. You're writing y is equal to 2x minus 4, right? And for various values of x, you were getting 3 points. Okay, so you were getting, say, if you had taken -1, 0, and 1 as your x, depending on those values of x, if you had taken -1, then you were getting -6 as your value. If you had taken 0 as your x value, then you were getting um, -4 as your value. And if you were taking 1 as your value, you were getting -2 as your y value. So the coordinate that you were getting were -1, -6, 0, -4, and 1, -2. You were getting three coordinates, and then you were plotting these on the graph, and with the help of a scale, you were joining these 3 points to get a straight line. Okay, now see, normally to draw a straight line, we actually need only 2 points. Okay, like say I have a point here and I have a point here. I need only 2 points to join them and make a straight line. I don't need 3 points. But here we were finding out 3 points. 1, 2, and 3. Why were we finding out 3 points? We were finding out 3 points so that the third point, in any 2 points if you take, and the third point, if it did not fall in line, okay, that is, if it did not fall on the same straight line, the third line, then you knew that your some calculation is wrong somewhere. So you could have checked the calculation once again. That is why we were taking out 3 points. But for to draw a straight line, 2 points are more than sufficient. Now, in this chapter, we shall study just the converse. In this case, the points will be given and you will be able to find out the equation of the straight line. In class 9, the equation of the straight line was given. This was given. You were finding out the points. Here, the points will be given and you will be able to find out the equation of the straight line. Okay. Now, not only point, but there is another thing which will help you in finding out the equation of a straight line. Okay, see, the point that I'm trying to make here is that even if 1 point is given on a straight line, suppose if I give you this point -1, -6 on the straight line, okay, still you can find out the equation of a straight line. But you will say, but I need at least 2 points. Yes, you need at least 2 points. That is why, because I have given you only 1 point, I will give you another thing, something called as the slope of the straight line. Slope of a straight line. I defined something called as the slope, or also called as the gradient of a straight line. Slope or gradient of a straight line. Okay. So if a point is given to you, and if the slope or gradient of the straight line is given to you, you can find out the equation of the straight line, even if 1 point is given. Okay. So there is another thing which will help you in finding out the equation of a straight line, even if 1 point is given, that I will mention later. Let me first show what a slope is. Now, the slope actually means, before defining the slope, let us define inclination of a straight line to the x-axis. Inclination of a straight line with the x-axis. Okay, inclination of a straight line with the x-axis. Suppose you have uh, the coordinate axis. This is your x-axis. And suppose you have a straight line like this, okay, and you have another straight line, say like this. These two straight lines you have, okay. Now, inclination of a straight line with the x-axis is defined as the angle that the line makes with the positive direction of the x-axis. Remember, the inclination of a straight line, let us call this line L1 and let us call this line L2. The inclination of a straight line is inclination of a straight line with the x-axis is the angle made by the straight line with the positive direction of the x-axis. Now, what do you mean by positive direction? With the positive direction of the x-axis. Now, the positive direction of the x-axis is taken as the anti-clockwise direction starting from the x-axis. So, suppose consider the line L1. Consider this line L1. What is the positive direction of the x-axis? You start with the x-axis and you start rotating anti-clockwise. Okay, and you reach here. Okay, this is your, if this angle we call theta, then this is the inclination of the L1 with the x-axis. So therefore inclination of L1 with the x-axis is equal to theta. This angle theta is called the inclination of the line L1 with the x-axis. What about inclination of the line L2 with the x-axis? You again start from the x-axis, start rotating in the positive direction. This angle here is called the inclination of the line L2 with the x-axis. Okay, let us call this phi. Inclination of L2 with the x-axis is equal to phi. Okay, so inclination of L1 with the x-axis is theta and inclination of L2 with the x-axis is phi. So remember the positive direction of the x-axis and be very clear with the positive direction of the x-axis. Okay, so now we come to the definition of slope. If you know inclination, then slope is very easy. Slope. What can we say about the slope of the line L1? Slope of L1, we call it M1. We denote the slope as M. Okay. If I call the slope of L1 as M1, then M1 is nothing but the tan of the inclination. That is this angle theta you see, you take the tangent of this angle, tan theta. Similarly, if you want to find out the slope of L2, you take the tan of the inclination. Okay, so each straight line will have an inclination with the x-axis, and if you take the tan of that inclination, you will get the slope of the straight line. So that is what uh, straight slope, the definition of slope is. Look at the first question here. Look at 1 1. The question here is, let us take it as an example. Find the slope of a straight line whose inclination is 30 degree. 1 2. Given
Good morning.
given what is the inclination given here? Inclination is 30 degree. Given inclination is equal to 30 degree. Therefore, what is the slope or gradient? Slope m, that is equal to tan 30 degree. And you know tan 30 is 1 by root 3, right? So that is what the slope is. Suppose if the inclination is given to you as 45 degree, then how will you find out the slope? Tan 45, which is 1. And similarly for others. Next, what if the slope is given to you and you need to find out the angle which it makes with the x-axis? Suppose it is given to you here. Let us see, take it from a problem. Let's say 2 part 2. Find the inclination of a line whose gradient is root 3. 2 part 2. Gradient or slope is given to be root 3. Let us say, let the inclination, I want to find out the inclination. So let the inclination of the straight line with the x-axis be theta. So therefore, what is tan theta? Therefore, what is the slope in fact? What is the slope? Therefore, slope m is equal to tan theta. And what is the slope m given here? Slope m is given to be root 3. So according to this problem, tan theta is equal to root 3. And how do you find out root 3? What value of tan is root 3? Tan of 60 degree is root 3. That means theta must be equal to 60 degree. That's it. So that is, first part was inclination was given. You needed to find out the slope. And the second part, you had the slope given and you found out the inclination. Okay, so that is, these are the two things. These are two concepts uh, on the slope. Let us now discuss a very important concept which is called the intercepts made by a straight line with the axis. Intercepts. We did this. Now, in case of a straight line, as I told you, not only points, even if one point is given to you, still you can find out the equation of a straight line. But along with that point, some other thing has to be given. The first thing that might be given might be your slope. Slope, once the slope of the straight line is given and a point is given, then you can find out the equation of a straight line. The other thing is if the intercepts are given. Let us see what intercepts are. Intercepts of a straight line with the coordinate axis. With the coordinate axis. Plural of axis is axes. Okay. So what are the intercepts? Let's see. You have your coordinate axis, x and the y axis. And you have a straight line. Say like this. Okay, you have a straight line like this. Then the x, we define two intercepts. One is called the x-intercept. X-intercept. What is the x-intercept? See, this straight line intersects the x-axis at which point? This straight line intersects the x-axis at A, this point. And this straight line intersects the y-axis at which point? It intersects the y-axis at, say, the point B. Then this distance, OA, taken with the sign, remember, taken with the sign, OA taken with the sign. In this case, we have OA as negative, right? Anyone who disagrees that OA is not negative? The distance OA taken with the sign is called the intercept. So the distance OA taken with the sign is called the x-intercept of the straight line, of that particular straight line. X-intercept of the straight line. How about the y-intercept? Similarly, the y-intercept is also defined. That is the distance OB. That is, this time we are talking about this distance, and again taken with the sign. The distance OB taken with the sign is called the y-intercept of the straight line. Okay, so if I give you an example here, sketch a straight line whose x-intercept is -5 and y-intercept is -3. Then how will you sketch the straight line? Okay, this is your coordinate axis. So if you see x-intercept is -5, so you take a point on the x-axis which is -5, 0, such that this distance here is from origin to this point, say A, is -5. Okay, we'll take it with the sign as I said. And now y-intercept is -3, so y-intercept is again negative here, right? So that means we have to take y in the negative direction. That means we take from the origin, we move in the negative direction 3 units, call this point B. So this point will be 0, -3. We have taken this length as -3 units. We are taking it with the sign. Okay. So therefore now if we join these two points, we'll get our required straight line. Clear? So if the x and the y intercept are given, then you can sketch the straight line. So this x-intercept is -5 units and the y-intercept is -3 units. Suppose if I ask you to sketch a straight line whose x-intercept is 5 units and y-intercept is -4 units, then how will you sketch? X-intercept, you take 5 units here. That means let us call this point P, 50. Okay, and y-intercept you take here Q, 0, -4. So you join these 2 points and you get a straight line. Okay, any question on x-intercept, y-intercept? Also, Another thing to note here is that if I given that a straight line, remember this because we'll be using this in the problems, given that a straight line has x-intercept -3 and y-intercept +4, we can say that -3, 0 and 0, 4 are points on the straight line. Is this absolutely clear? Or any questions on this point? If you see here, I have given you x-intercept as -5 and y-intercept as -3, and I have drawn a straight line. Do you see that the straight line passes through -5, 0 and it passes through 0, -3 because the x-intercept is -5 and the y-intercept is -3. Okay, so whenever it is given to you that the x-intercept is -3 and the y-intercept is 4, you can assume that it must pass through -3, 0 because x-intercept is -3, and it must pass through 0, 4 because the y-intercept is +4 given. This is very important. We shall be using it in the problem. Okay. Now, now we will see later that if one particular point is given, or if even if the slope is given to you, and if the y-intercept is given to you, we can find out the equation of a straight line. Even if you don't know any point on the straight line, even then you can find out the equation of a straight line. What will determine the equation of the straight line? The slope of the straight line and the y-intercept of the straight line. If you know the y-intercept and if you know the slope, you can find out the equation of a straight line. We shall see this later. But once we have done this, now we come to the standard forms of the equation of a straight line. Standard forms, very, very important concept, standard forms. Let me see before this if I can take an example from the book on a particular sum from intercepts. See, no, there are no problems. So let us discuss standard forms first. Standard forms. Of the equation of a straight line. Okay. The first standard form is equation of a straight line. Remember this, equation of a straight line parallel to the y-axis and at a distance of a units from the y-axis is x is equal to a. If you remember, I had mentioned this to you last year also when I was doing straight lines, but still. So if you have the coordinate axis, if you want to sketch, suppose you want to sketch x is equal to 3, x is equal to 3, this straight line you want to sketch on the coordinate axis, then what is the form here? X is equal to a, right? X is equal to 3 means x is equal to a, where a is what? Here a is plus 3 units, right? On comparing x is equal to a with x is equal to 3, right? This is, we have got a is equal to 3. Now we want to sketch this straight line. Now you know that any straight line of this form, x is equal to something, will always be parallel to the y-axis. So what you do here is you take 3 units distance because it is plus 3 units. See, a we have got plus 3 units here. So what you do is you take 3 units, 1, 2, 3 units plus 3 in the positive direction of x, and you draw a straight line parallel to the y-axis passing through. So this point is your 3, 0. This distance is your plus 3 units. And the straight line here that we have drawn has the equation x is equal to 3. Suppose you need to draw x is equal to minus 4. How will you draw? Here a is equal to minus 4 units, right? On comparing x is equal to a with x is equal to minus 4, right? So I've got a is equal to minus 4. So what you do here is you take 4 units distance from here in the negative direction, 1, 2, 3, 4, okay, and you draw a straight line parallel to the y-axis. So this point is your minus 4, 0, and this straight line has equation x is equal to minus 4. What you must note is that any point that you take on this straight line, any point that you take, any point that you consider on this straight line will have your x coordinate equal to minus 4. Y coordinate may change. Okay. The y coordinate may be anything, but the x coordinate will remain minus 4. Similarly, here on this straight line, if you see any point that you take on this straight line, any point that you consider, your x coordinate here will remain 3. The y coordinate will change only. Your x coordinate will remain the same. Okay. Understood? So this is something that you must take note of. Let us come to the next standard equation. Let us call this number 1. Equation of a straight line parallel to the x-axis. Number 2. Equation of a straight line parallel to the x-axis and at a distance of b units from the x-axis is a straight line parallel to the x-axis, is a straight line of the form, okay, has equation of the form since it is parallel to the x-axis, it will always have an equation of the form y is equal to b. For example, you have your coordinate axis just like your previous problem, I mean the previous standard form. You have your coordinate axis and you have to draw, say y is equal to 3 on this. How will you draw? Comparing y is equal to 3 with y is equal to b, we get b is equal to plus 3 units, right? So if you want to draw this straight line y is equal to 3, this will always be a straight line that is parallel to the x-axis. Remember, any straight line that is of the form y is equal to something will always be parallel to the x-axis. But how will you draw? Since it is y is equal to 3 and it is equal to plus 3, you will take 3 units in the positive direction. And you will draw a straight line passing through this point. This is your line y is equal to 3. See that we have taken 3 units here, plus 3 units in fact, in the positive direction. And see that this point here passes through 0, 3. Okay. So what you see, what you also must notice here, that any point on this straight line y is equal to 3 will always have the y coordinate as 3. The x coordinate can be anything, x coordinate can change. But any point that you consider, it will always have a y coordinate 3. Okay, this is something that you must notice. All these we shall be using in the problems. Next, if you want to draw, say y is equal to minus 5. How will you draw? Comparing again y equal to minus 5 with y is equal to b. We get b equal to minus 5 units. Therefore, how will you draw minus 5? You take y is equal to minus 5 has to be parallel to the x axis. You take 5 units here. 1, 2, 3, 4, 5 units. And then you draw a straight line that passes through this point and parallel to the y-axis. So this is your equation, y is equal to minus 5. Again, note that any point that you take on this straight line will have your y coordinate equal to minus 5. The x coordinate can fluctuate, x coordinate can be anything, but definitely any point that you take will have the y coordinate minus 5. Okay. So this is something that you must remember, okay, for your problems. Now, my question to you is that if I take a straight line, say like this.
Sir,
Yes.
sir, in the above example, you wrote minus 3. Every line passes through that y will be minus 3. Sir, minus 2, why minus 3?
Why minus 3 where?
Sir, above.
I've not written
Yes,
minus 3,
sir.
I've written 3. I've given a dash there. That's not minus.
Oh, oh. Yes.
Okay.
Okay.
So uh, now if my question to you is that suppose if I take a straight line, x is equal to this line, what is the equation? Let us say this distance is, minus 5 units. Then what should be the equation of the straight line? We know the equation of the straight line will be x is equal to minus 5 because it is parallel to the y-axis. So my question to you is, what should be the y-intercept of this straight line? Can you tell me what should be the y-intercept of this straight line? Can anyone tell me what should be the y-intercept of this straight line? Auric, can you tell me what should be the y-intercept of this straight line?
So can you scroll it down?
Hmm. Okay, y-intercept of this straight line. Tell me both, in fact, x and the y-intercept, both.
So minus 5, 0.
Okay, Archita. Minus 5, 0 what? Minus 5, 0 point. I'm talking about the x-intercept and the y-intercept. Tell me separately, what should be the x-intercept and what should be the y-intercept? Tell me separately. Yes, can anyone tell me? Smriti, can you tell me?
So x we can take it as a, 0 and y 0, b.
No, I'm talking about the x-intercept. I'm not talking about the coordinates. Tell me the x-intercept of this straight line. Suppose this x is equal to -5, I call this L, or say L1. What should be the x-intercept? And what should be the y-intercept? What does the x-intercept and y-intercept mean? See, x-intercept, as I told you, is the distance of the origin from the point where the straight line intersects the x-axis. So if you see, the x-intercept will be this distance, right? This is very clear. X-intercept of the straight line is -5. Anyone who
Minus.
who disagrees with me? Now the question is, what should be the y-intercept? What is the definition of y-intercept? The definition of y-intercept is the distance of the origin from the point where the straight line intersects the y-axis. Now tell me, where does this point intersect the y-axis? Does it intersect the y-axis? Does it intersect the y-axis? It doesn't, right? But in mathematics,
Yes,
we
sir.
say that two parallel lines, they intersect. They intersect at infinity. Therefore, we say that the y-intercept has to be infinity in this case. Suppose if I take a straight line like this, suppose if I take a straight line like this, okay, and suppose the equation of this straight line is y is equal to, since this is parallel to the x-axis, the equation of this should be y is equal to, say, -2. Then this distance is your -2. So in this case, your y-intercept is how much? Y-intercept is -2. But what is your x-intercept? Does this straight line intersect the x-axis anywhere? Does this straight line intersect the
No.
x-axis? It does not intersect. It is actually parallel to the x-axis,
No, sir.
but it intersects the x-axis at infinity. Therefore, we say that x-intercept is equal to infinity. Okay, so that is what. So we have finished the concept of standard equation of a straight line. Two standard equations we have finished. Intercept, slopes we have finished. Next day I will continue with the other standard forms.